Oh, dear spaghetti monster, please shine your ragu goodness upon me and allow this project to work worth a damn for, let's say, the next 45 minutes, maybe 60 if this runs a little bit long. Please, oh dear all-powerful spaghetti monster, grant me this wish. Welcome back. As you know, I am Eli, the computer guy, and in today's class, I'm going to be showing you how to build an IoT power relay that is controlled by a Blues modem. Oh, spaghetti monster who art in the pasta bowl, hallowed be thy name. Please, please let this project work. Okay, so basically what we're building is, so I'm using this light as a demonstration, and I have this relay. So what a relay is, essentially it's a power switch that you can control by outside signals. So this is something that I bought off of Amazon a while ago for about $30, and what I like with it is it's all completely contained. I don't have to worry about trying to electrocute myself. There are other power relays out there without all the container and all that kind of stuff, but if you go, you might hurt yourself, right? So this is a nice little relay unit. This is connected to the Blues dev kit, right? So we've been using the Blues IoT modem. That's connected onto the expansion board. There's something called a Sparrow card. So the Sparrow card is basically an Arduino clone. And so there are configurations inside the modem itself. And then the Arduino basically is able to read the information that comes into the modem, and it's able to send information to the modem that then goes up to the network. So this is on the cell network. Right? So it's on the cell network. This communicates with their platform. There's a platform called Notehub with its own API. And so basically what we're doing today is I created this web app. So this is a simple web app using Python and a web app framework called Bottle, simply just to create a web page. This is actually running on my computer here. And the idea is I click on, this will go from my computer, from my server, to Notehub through their API. Once it goes to their API, then the modem is supposed to pick up that command, and then based on if the value is on, it should turn the relay on. If the value is off, it should turn the relay off. That's what's supposed to happen. So let's click the on button. Okay, so that went through. If we go over, we take a look at Notehub, we can refresh this. We can see the command for on went to their platform. And so now within, I don't know, anywhere between 10 seconds to never, hopefully the light will turn on. Yay! And now the light turned on in about 46 seconds. So there is a delay. There is latency, as they say. Now I can click the off button, and hopefully the switch will click off within, I don't know, let's say 45 seconds or so. Let's see how long it takes. Ah, there we go. And it turned off. Yay! The demonstration worked. Thank you, Spaghetti Monster. I shall give you my firstborn child. So basically, this is what I'm going to show you how to build today, because I think it's interesting. One, from just a functionality standpoint, this can be very useful, and also from that architecture standpoint. Again, we're talking about the modern world, and we're talking about IoT. Thinking about how architectures are designed is incredibly important. And this whole system here, we have different networking, the devices and systems and all that kind of thing, different protocols. We have API calls. We have a whole bunch of different things going on here. And so even if the demonstration doesn't work, I think it's really interesting to just take a look at this from an educational standpoint. The first question that you're going to have with this kind of setup is this whole question of why. Why would we want something like this, even if it worked perfectly with almost no latency, but we could click a button and turn things on or off? Well, this can be very useful as something called out of bandwidth management in the IT world. So what out of bandwidth management management means is you have your normal pipe going to your systems, right? To your servers, to your networking equipment, all of that kind of stuff. What happens if one of your routers freezes up? What happens if one of your server blue screens of death, or whatever the Linux version is, I suppose, and basically you're no longer able to access it? You can't remote desktop, you can't SSH, you can't get into it because it's entirely locked up. Well, a lot of the power distribution units now, PDUs, basically smart power strips that they have, are actually a lot like this particular power relay, where you can connect them to an external device to power cycle. So you can power cycle either the entire PDU, or many times you can power cycle individual outlets on that PDU. So if your system completely locked up, you could send a command entirely separate from your normal ISP connection, and basically to do a power cycle of the port or of the power strip, and that might be able to fix the problem for you. The other thing to be thinking about is, again, when you start thinking about IoT and you start thinking about like simple solutions, remember with this modem or modems like this can send basic information to you, and you can send basic commands to it. So you can have a sensor array on this, temperature, humidity, water sensors, those types of things. If this detected something, it could send information. You could be on a dashboard like this, and then you could click an on button, and that on button could be to turn on the AC, to turn on a water pump, to turn on lights, those types of things. So is this something that everybody is going to use all of the time? No, absolutely not. But I do think it is a very interesting concept for niche situations. One of the reasons why I keep playing with blues, even though I want to strangle it, is also because of their price point and their basic business proposition, you know, aside from the technical issues, where basically with this, you buy the modem for $50, so the or $60. The cell modem on this costs $60, plus an expansion board costs another $15. So you're paying about $75. You can connect this to an Arduino, or you connect this to a Raspberry Pi. The thing is, when you pay that amount, you get 500 megs of data for up to 10 years. And then there's some stuff with the API calls. But basically, you can pay one fee for this thing and be done with it. And it's not bad. If you have to increase the amount of bandwidth you need, it's literally $10 per 500 megs, and that's continuous. If you look at a lot of the other LTE data providers, they may be inexpensive on a per month basis, $10 per month. But think about that. That means you're paying $120 per year per device in the field, even if all it's sending is JSON, or even if all of it's sending is very basic text, right? The nice thing about this is you pay that $10, you get 500 megs basically as an amount, you burn through that, and then if you need more, you buy more for $10, and if you don't need more, then that's that one fee. And so what's really interesting about this is, again, when you think about environmental control systems, when you think about out of bandwidth power cycling systems, when you think about anything where basically you just need to flip an on-off switch, or you can do pulse width modulation, PWM, so like be able to turn the speed up or take the speed down. There's a lot of stuff that you can do with this. So anything, basic text-based remote type stuff, I think at least on the whiteboard, this is an incredible solution. So I definitely think this is something that you need to be thinking about, whether or not blues is the path you go down. Now, I know this may come as a shock to you, but I'm not actually sponsored by Blue. So I am doing these videos because I actually really like the concept, and I really think, if it does what it's supposed to do, this could be an incredibly tool in your toolkit. So I know it's going to come as a shock. Don't get a dime from Blues, or frankly, anybody. It's shocking with these tech companies. If you don't state completely glowing reviews about absolutely everything that they do, they think you're the Antichrist or something. It's just how it goes. But anyways, when we start taking a look at Blues, right, and we do FTC compliance for not getting any sponsorship money, there are some quirks with the Blues. So again, I've been dealing with this for about 2 weeks now. I've been spending about 3 to 4 hours a day trying to build different projects. And this is quirky. To be clear, like, It is quirky. I'm actually kind of surprised that this project is working. I recorded an entirely separate video basically for this project, and yeah, it was a disaster. And the weird part was, is sometimes this whole system works perfectly, and sometimes it works like hot garbage. And I didn't really do anything in between. Basically, why I'm doing this video today is I did clean up the code a little bit just to dot the I's and cross the T's. I cleaned up the code just so somebody couldn't say, oh, there was an issue here. But basically, if you're going to be using this, just realize it's like there's just some weird like connectivity things where when you send a command through the API, this thing is supposed to automatically pick it up within a pretty quick amount of time, and many times it just simply doesn't. I've had this thing lock up, and where I've had to walk away after 20 minutes, and you know. I don't know what happened because I got tired of waiting. So that's kind of one of the things with this. And so with that, there's some considerations that you have to be thinking about if you're going to be using this type of thing in your infrastructure in any type of capacity. One thing you have to be thinking about is what is the latency going to be? So the latency is how long it takes for your signal, not the entire size of the payload, but the signal, basically to go from wherever you're sending the command all the way down to the device itself. So with the script that I have running today, if it works how it's supposed to, it could be up to 2 minutes and 10 seconds from when you send the signal for on or off to when this thing is supposed to respond. Depending on what else is going on in the modem, quirkiness or whatever, it might take longer. It might take 4 or 5 or 6 or 10 minutes. Because remember, this thing has to connect to the cell network. It has to do its whole authentication thing. And then it has to go and communicate with NodeHub. And so even if everything is working completely perfectly, you may actually have a latency of a couple of minutes. And so this is something that you need to be thinking about when you're going to be building this type of system. It's not necessarily a bad thing. It's just one of those things you have to keep in mind. So with that, one of the considerations is if you're dealing with a device like this, where you're going to be controlling something outside of your view, is that trying to figure out a way that you can get feedback to verify whether this thing has actually turned on or off. So in the previous class, I showed you how to send communication from the modem up to the API and for that to be sent to your server. So one of the things that you may have is basically you could have like a light sensor on this. So basically, like if you're turning on a light, you got to have a light sensor here. So you send the signal to turn on the light sensor then detects the light, and then it sends you back a data saying that the light is now on, right? That is something that you could use as a feedback mechanism to verify that the communication has actually gone through. This is something you consider. The other thing to be considering is like making sure you can actually turn something off. Again, turning something on is something and turning something off is something, right? So if you have a pump, if you have a fan, if you have an air conditioning unit, something like that, and you click the on button, one of the things, in case there's a problem with the communication, is you may want a timeout feature. When I click the on button, I want this relay to be on for 60 minutes unless it receives another signal. So basically every time it receives a command, it resets the timer for another 60 minutes. And that way, worst case scenario, the AC is only running for an extra hour, or the relays are only running for an extra hour versus possibly days. Again, that's something that you have to consider is if you're controlling these devices and they're 10 miles away, 100 miles away, 3,000 miles away, if something gets stuck to the on position, that might actually become a major issue for you. And so again, this is one of those things you need to be thinking about when you're designing these types of systems is basically how do you verify that the command that you sent actually worked, and then how do you make sure that if the system freezes up at a particular time frame that it doesn't cause additional problems. So now let's take a moment to talk about architecture and basically how this overall system functions. So the first thing that we have is the Blues modem, the IoT modem. So there's something called the note card. This is a note card, and basically on that note card, it has its own configurations. So you're going to do an initial setup process to set up the note card. You're going to say basically how often it's supposed to talk to the cell towers, and you're going to do some other configurations like that. And that's actually going to be within the note card itself. You're then going to have some kind of expansion module, and on top of that, you are going to have something like an Arduino or a Pi. An Arduino is a microcontroller, so the Sparrow that's on here is an Arduino clone. Raspberry Pi is a full-fledged computer. So they have modules that allow you to connect normal Arduinos to one of these things, and they have hats that allow you to connect one of these things to a Raspberry Pi. And so this is basically where the brain is going to be. Any parsing of values, that's going to occur here. If you're actually going to store the data locally, that's going to happen here. The if-else statements, all of that type of stuff. So basically this is going to be the one that's really is sending the command to communicate or send data up to the API, and then it's going to be processing the data, doing that type of thing. So with that, then the Blues is going to connect to the cell network, and from there, this is going to connect to NoteHub. So NoteHub is Blue's platform. So this thing, again, it's important to understand how this system works. This will only communicate with NoteHub. It doesn't send SMS. It can't get to a web page. You have to go through NoteHub, which is its own quirk. It could be good, could be bad. It depends on your situation. So it goes up here. Now, NoteHub, basically, they have an events table. So information that comes in goes to the events. Information that comes in from the outside world also goes to events. And basically, this is able to route. So basically, depending on what comes in, this is able to route out to externally through something called webhooks, or down to the modem. It's just automatically able to download or send it to the modem. And so, for NoteHub to communicate with the outside world, there is an API. So just like in Twilio or something like that, you have an API. So you can send information in using this API that will then go down to Blues. So our computer is sending in through the API that goes into NoteHub. NoteHub then queues this up to go down to the Blues. Once it hits to the Blues note card down here, the Arduino then reads the values and supposedly turns the light on or off. So, right, so NoteHub is obviously on the cloud, and then down here we have our computer. So basically what I have set up right now is a web server. So this is, again, this is simply Python. So this is the Bottle web app framework using Python, and I'm running this on the local computer to give me this particular interface. Now, the important thing to understand about this is this could be this user interface is UI. This could be Android. This could be iOS. This could be your web app. This could be a desktop application, whatever else. Basically, I'm just using Bottle here. So here we have the on, and we have the off, right? What happens is when I click on or when I click off, there's a curl command that's run. So curl is a command line tool for interacting with the internet. And basically with this is going to go out and get something called an OAuth token from NoteHub. From Blues, right? So basically, for their communication, they use a OAuth instead of a username password system. So basically, when I click on or off, that's going to go out, go to OAuth. It is going to get a token back. Once it has the token, it's then going to take that token. It's then going to take the command on or off, and that is going to be sent to NoteHub through their API call. That is then going to go into the event, which should then be routed down to the modem, and then it should be read by the Arduino or the Pi. And this is basically what the architecture of this system looks like. And so again, it's an interesting thing to be thinking about with doing API calls and cell communication and all this kind of thing. Basically how you would design this if you were going to be building your own type of IoT power relay. So now let's take a look at the code. So for this project, we have 2 bits of code. We have main.cpp. So we've created this in platform IO. So when you go through the quick start guide or whatever with Blues, basically they are going to recommend that you use the platform IO VS Code extension in order to write your Arduino code and upload it to the Arduino. And so that's what we're doing here. And we have the main.cpp. Then for the Python script, basically this is what creates our web app. We simply have an on-off.py bottle Python script, and this is what provides us that little web application that we've been taking a look at. So let's go over and take a look at the Arduino code. So here's the Arduino code. Since we're using platform IO, we're going to include the Arduino library. Then we're going to include the Notecard library that gives access to the Notecard tools that we're going to need. We're going to find USB serial for a serial connection. We're going to find the product user ID. So basically, this is for your project. So Eli the computer guy, Eli, IoT demo. This is basically the ID for the product, and the product is the overall project. Notecard is Notecard, and then we're going to create an int value here. We're going to be counting up the notes that have been sent to this Arduino. We're going to use this to actually delete notes. One of the weird things with how the note card works is, as far as I understand, all of the notes get downloaded onto the note card. So the note is basically the message, but you can only read them sequentially after one has been deleted. So if you have 4 notes and you read one, and all you do is read it and then close it, and then you go to read the notes again, you will still continue to get that one note. You actually have to delete notes in order to see the next note in order. Again, one of the quirkiness, the design philosophies for this thing. And so we're going to use this value a little bit later so that we can delete notes. Basically, if the number of notes is above 1, delete the note. We're going to come down here to setup. We're going to delay by 2.5 seconds. We're then just doing a troubleshooting routine. Basically, with this troubleshooting routine, we're going to make the light blink. Every time this thing is turned on, the light will blink, and this shows us that our Arduino is communicating with the relay and our light is working. Again, you can spend a whole lot of time doing troubleshooting, trying to figure out what's wrong with your code when the light bulb burned out. So whenever you're going to be writing your code, you do need to put in little troubleshooting routines just to verify the basic system is doing what the hell it's supposed to do. Before you get into the insanity of API calls. Your API call will never be written properly enough to get around the fact that your light bulb has burned out. So anyways, pin mode 13, we're going to set it to output. We're going to write it to high. We're going to delay for a second, and we're going to write it to low. So it's going to turn on for a second, and it's going to turn off. Troubleshooting. USB serial begin at 115.200. This is what they recommend for whatever reason. Notecard.begin. So we've actually got to begin our note card. Note card set debug output stream to the USB serial. So the note card information that comes through will go out to the USB serial if you want to take a look at that. We'll show that to you later. Then we're actually going to do the note card settings. So again, remember, in the Blues world, can you say it in JSON? Everything is JSON. So with this, what we're doing is we're creating a JSON object, notecard new request hub.set. So hub.set is going to set the values on the modem, so on the modem itself. Add string to object. So we created this object. We're going to add the product. So the product user ID, the ID that was up there. We're going to add string to object. We're going to set the mode to continuous. So the mode to continuous is supposed to mean is that it's always connected to the cell network, right? And the sync true means whenever something comes in to the Note Hub system, it's supposed to automatically sync. That's what those settings, as far as I can tell, are supposed to do for you. Anyways, then we come down here, gonna add int to object, so we're gonna set the interval to 2. So this is a recommendation that Blues has. Basically, again, we're dealing with technology, there are quirks, things are supposed to automatically happen, and sometimes things don't automatically happen. So the idea with this interval here is this is a minute number for basically as a backup. If things don't auto sync for whatever reason, then at least, basically at least, it will try to sync every 2 minutes. And so that's where I say the latency on this could be theoretically, if everything worked properly, 2 minutes and 10 seconds, because if for some reason this thing doesn't communicate automatically like it's supposed to, there's supposed to be a default of no more than 2 minutes for this thing to automatically try to do a synchronization and pull the value down. I also have a 10-second delay, a little bit down in the code, and so that's where we get to the 2 minutes and 10 seconds. And so again, this is one thing that you need to be thinking about whenever you're creating these types of systems. Things are automatically supposed to happen, but what happens if they don't? You should have this backup, which, well, it exists. It's a configuration. Then we do notecard.sendRequest. So we're sending this JSON request. So all of these values to hubset go up, and now for the product ID, we have it set to continuous mode, true, at an interval of 2 minutes. We then come down here to the loop. So with microcontrollers, again, all they're basically doing is a loop. This is not a computer like a Raspberry Pi. It's just looping through. From here, what we're going to do is we're going to get the request. So basically, we're looking for the message. Basically, we're looking for on or off, right? Again, everything is in JSON. So if J request notecard.newRequest note.get, so this is how you get a note from the system. This is that. So the response is going to be actually running that query, right? So we're going to run this query, and that's going to be the response. This is also going to come back as a JSON value, and then we're going to send any debug information out to the log debug. Then we're going to come down here. Data equals get object from the response body. So basically, you get the JSON value, right? You know how JSON values, you have the parent, then you have the child, then you have the grandchild, and the great-grandchild, and all that kind of thing. Basically, every child is its own object. You can't just do message, body, whatever. You have to get the message. Once you have the message, right? Or you have to get the body. So you have to get the body. Once you have the body, from that you pull out the next object, and then you can get anything inside that, any value inside that object you can get, but if it's a child or grandchild, you actually have to pull it out as individual objects, right? So basically the response is the note. Then what we need to do is we need to get the body. So the body is a child of the note. We need to bring that back as data. Then char message underscore char equals j get string data message. So basically data is going to be the body. And so we're going to get the message from the body, and that's going to go to a character. Then I'm going to turn the characters into a string. I find that easier to deal with. So string, message char, message. We're going to turn that into a string. We're going to print line, nothing. Then we're going to print message, and then we're going to print what the message is. So on, off, or something else. And then we're going to notecard.delete response, the response. This is an interesting thing with how Blues does it. Apparently, from what I've been able to read, they don't do their own memory cleanup. So if you do not delete the response, you can actually run out of memory as it just kind of bogs down your system. So don't forget this delete response. Then we have basically simple, if message equals on, turn on. Else if message equals off, turn off. Else, so Bob is the command. We get another command. And again, think about troubleshooting. Something else, basically high, low. We get this thing to blink to show us that we're getting some other kind of command in. So again, when you're doing these API calls, when you're sending things, it's really easy to send an extra character to screw things up somehow. Maybe you didn't do the capitalization properly. Maybe you didn't sanitize your string or whatever else. So by having this thing blink, if you get something other than on or off, again, that's just a little troubleshooting tool. Then down here, again, we need to delete the notes that come in. You only are able to read the note, and so you have to delete to go back. And so basically what this is doing is if there's over one note, we need to delete. So this new request is we're doing new request for file changes, add string to object, file data to QI, response equals Notecard request. So basically it's asking for file changes within data QI, total equals get int from response for whatever total is, print out total messages, the number, serial print that value, and then delete the response so we don't have any memory issues. If the total here is greater than 1, basically we're going to get the note, the same thing that we did before, but the request that we're doing here is delete equals true, and then we're simply going to send that request. There is no response. So here we're deleting the response. There's no response here. We're simply going to send that request. And so that deletes the note, and then down here we're going to be delaying by 10 seconds. And so this is basically how the Arduino code works. And again, one of the things you need to be thinking about is once you start dealing with the Arduino world, you're dealing with your own world of coding and things. Again, that's one of the frustrating things is when you go to Arduino, whenever you're writing out stuff that you could write out in Python in a heartbeat, oh, that's simple. A lot of times when you get to Arduino, you have to build and you have to do stuff that just isn't what you're used to. Again, like normally if you're dealing with Python and you need a value out of JSON, right, you just get the frickin' value out of JSON. You don't have to go through here and convert things into objects and pull stuff out, and that's a bit of a nuisance. So this is the basics of what this code looks like. Then we come over to the bottle code. So again, I'm all aflutter about bottle. My favorite toy, my two favorite toys right now are Bottle and SQLite. And I thought Blues was gonna be my next favorite toy. I don't know. Putting a dunce cap on Blues right at the second. So now let's go and take a look at the bottle code. So again, just to be clear here, FTC compliance. I love Bottle. My two favorite toys right now are Bottle and SQLite of all things. Everybody else is all excited about AI. Like, have you heard of SQLite? Yay! Anyways, that's the kind of geek that I am. Again, I like Bottle. It's a micro web app framework. It allows you to spin up a web app, lickety-split, incredibly easily. And basically, when you run the script itself, you don't have to do an external call. You can literally just run the script itself. And that will give you the web page for you to interact with a web app. So basically, if you want to build some kind of web app, but use it more like a desktop application, Bottle is just an incredibly easy way to go. So anyways, from Bottle, import route, run a request, import JSON so we can deal with JSON, and import OS so we can do some OS things. We have a function here for modem. So this is where we're going to be sending the commands up to the API, and then we have a route. So basically, whenever you deal with these web app frameworks, you're going to have routes, and so /switch. We have the function for that route. Down here we have run host equals 0.0.0.0. So basically, this means any IP interface on my computer at port 80. I just make life easy by port 80. If you do port 80, you don't have to do the colon other ports. And debug equals true. It is my system. So if there's a problem, I'd like to know what the hell the problem is. So basically with this, if I go to 127.0.0.1/switch, I will then get this web page. We take a look at this. Basically here, command equals request.query.get command. So the switch page, when the switch page gets written, this is the HTML, we have two hrefs with get values. 127.0.0.1, switch, question mark, command equals on, switch, question mark, command equals off. So these are those two hyperlinks that you saw. And this is sending, when we talk about sending a get value, this is where you send a variable and a value through a URL. So command equals request, query, get, and whatever that command value is. So on or off, or if somebody tries to hack the system, Bob, right? Then we have the modem function. The modem function is up here. And so when we get the command, we are going to send the command value to the modem function. Let me close this for a second and then go up to the modem function. So now here we get into curl. So in order to do their API call, they want you to use curl. So again, what programming language do you use? It depends on what the API requires. That's literally what it comes down to, right? They use curl. That's one of the reasons we're using OS. Now you can send curl. There's actually a specific Python curl module that allows you to send curl that is supposed to be more secure and better and all those kinds of things. The reason that I'm doing it this way is just so everything can be written out and you can really see what's going on. If you want to use that module, again, that is technically the better way to go. Again, with this, when you're trying to do education, sometimes with education, you don't do the best way to do the way that's understandable. So just kind of keep that in mind here. We have an ID for the device, we have an ID for the project, we have an ID for the client, and we have a secret. All of this is going to be getting deleted soon. So yes, that exists. We're going to do a query. So the curl. So basically, we're going to create query. This is going to be the curl statement that's going to go to the operating system, and this is going to get us the token. So basically what an OAuth token does is we make a request for the OAuth token. Once we have that token, we then use that going into the future to make our API call. So when you're doing API calls, you can do the username and password, you could do a secret. There's a whole bunch of different ways of doing API calls, and they decided to do the OAuth token. So ergo, we use OAuth tokens because that's how it is, right? Basically with this, we plug in our client ID and we plug in our secret, and then we're going to get a response. So response equals os.popenQuery, and then we're going to read this into text. So basically popen is the function within the OS module that actually runs that query that we created and then sends the output to response, right? So not only does it run it, but it sends the output to the response, and we're going to read that as text. We're then going to do JSON.loads that text response so that now that response is a JSON value. So we can just simply grab out the JSON value. Again, one of the things I like about Python is pretty simple. So token equals response, the value for access token, and then we're going to print out the value for access token, the token, just so we see what that looks like. Again, not great for security, good for education. Our new query is going to be our next curl statement. Again, this is going to go to note file, project ID, the device ID, then the data file. So we're going to be sending this to the data file. If you have a different file, you would change that. Authorization bearer, we're then going to feed in the token. Then here, we're basically going to do message and the value for command. Now, one of the things, this starts to get a little bit complicated with the F string when you deal with JavaScript or we deal with curl, because you start using the same characters that you would in Python, and so it can get squirrely. So when you see squiggly bracket, so basically, if you have to have a squiggly bracket within the F string for, again, Python or curl or whatever, another squiggly bracket escapes. So an escape tells the programming language, ignore this, just treat it like normal text. So a squiggly bracket in front of a squiggly bracket means escape and use this squiggly bracket just as text. This isn't Python. Then we have to do the slash. We have to escape the double quotation marks here because we have single quotation marks here, we have double quotation marks here, we have single quotation marks here. You only got so many types of quotation marks. So basically, I'm using the double quotation marks here and then escaping out of them. So body, so this is where we create the JSON. So we create the value for body. In that, we create the value for message is the command. So within body, message is the value for command, on or off. And then we're going to do os.system. So this is where we send the command to the system, but we just send it. I don't really care about a response, so we're going to send that new query. Print command was on or off or Bob. That's basically how that works there. Again, we come back down to the switch. That command goes off. Then we create a value for page. So this is just the HTML for that page that you see. Light switch. Here are the get hrefs. Then we have a footer. The footer says light is and whatever the command value is. So you have these clicks, and basically when you click, this will change it to either on or off, and then the page equals an F string page plus footer, and then we're going to return the page. And when you return the page, that's where you get the on, the off, and the light is off down here. So this is how this code works. So now that I've shown you how the code works, I kind of want to show you it in action. Basically, take a look at the terminal and the serial monitor. So with this, I now have my Swan board connected directly into my computer, and I have serial monitor on, and this is giving us all the results on the serial monitor. So that debugging thing that I showed you in the Arduino code, the serial write, all of that kind of stuff, that is what we're looking at here, right? So file, let's see here. So we come here, request, we come note get, it gives us a value, the time, the body, the message is off, and then we come down here, message is off. We then go take a look at the file changes, see how many files there are. There's a total of 1 file, right? Also, if we go over to terminal, basically this right here, this is all the output for the bottle script that's running for that web app. We can see command is off. We can see the token here. We can see all of this output, right? So if I go over and I click on the on button here, so I click on, right? Then I come back here. We can see down here, I don't know if you can quite see it, command was on. So this is the command that got sent out from the web app. I can then go to NoteHub, and on NoteHub, I can see that the command on was sent. So see the command on was sent. And then I can come here to serial monitor. And, as said before, anywhere between 10 seconds to 2 minutes and 10 seconds, hopefully something will turn on, right? So this is still reading the off value. So even though it is up here, right, we can tell that in events that NoteHub has received the on message. For some reason, it has not come down to our computer yet. And if it takes any longer, you're going to start to see the Eli dance for a second. You got to do something, right? It's entertaining. So it's still reading off for whatever reason. What? Okay, so the light turned on, so the message is now on. And I can do the stop monitoring, right? So the message came in. When the message came in, the total number of messages were 2. So therefore it deleted one of the messages, right? And then the message, then the if-else statement was run in order to turn the light on, right? And so again, with that latency, that was about a 2.5 minute latency. So yeah, you're not going to be playing Call of Duty on this thing. But if you need to turn relays on or off or do that type of thing, that's basically how all of this works. So there you go. Now you know how to build an IoT power relay using a Blues note card with a Swan dev kit. And, if you eat a lot of pasta and sacrifice a lasagna at the perfect time during winter solstice, maybe your system will work. But anyways, basically with this, again, I want to show you how you can use these different types of systems, again, to do network communication. Nowadays, so many times when you think about networks or when you think about computer communication, you think about DSL or cable or fiber lines, everything is TCP/IP4. One of the interesting things is that there's so many other systems out there for being able to do things like data communication, and we're just not talking about them anymore. And again, that's one of the things that I just find a little bit weird. So with this particular system, again, you can turn on anything that essentially has a power switch. You can turn that on. Again, with something called pulse width modulation, you can set basically the speed of the thing that you turned on. And then there's other stuff in here where you could actually do more interesting things, but that'll probably be for a different class. Now, I will tell you with this, again, I've been snarky as hell with this particular project and this note card. because I'm at about the end of my patience with this thing, to be honest with you. But what I do want to tell you is I actually believe in this concept. If I did, again, I know the CEO actually follows me. Oh, this might be horrible. Anyways, here's the thing. I actually believe in this concept. I truly, truly believe in this concept. These salespeople sold me on the concept of this thing. Again, you spend one fee, you get 500 megs of bandwidth, right, up to their systems. Again, as long as you're reasonable about the API calls, there shouldn't be a lot of API expense past that. You have that one fee. This actually makes a lot of sense for these simpler type projects. Again, if all you're sending back and forth is text, and then you're able to process that on either side, that can be incredibly valuable. And again, if you look at the other solutions out there, I mean, I'll be honest, I looked at the competitors. I looked hard at the competitors. And again, a lot of the competitors out there, you have to buy the modem. So there's an expense for the modem itself. Then a lot of the prepaid plans, you're spending $10 per month for that. Again, if you're sending video or audio files or images or things like that, that might make a lot of sense. If all you're sending is text, you want to be spending $10 per device per month in order to do that. So I do believe in this. I find the dev kit that they sent to be quirky and very poorly documented. With Blues, I feel like they give you a lot of information that's difficult to parse out, kind of difficult to understand exactly what's going on. And so there's some issues with that. And then beyond that, using Arduino, again, if you're used to the Python world, Python's just a hell of a lot easier if you're dealing with JSON and a lot of this kind of stuff. So all of this gets to be a bit of a complicated mess, especially if you're not a complete expert. Again, in Arduino, if you're not doing Arduino pretty regularly, this can be a bit confusing. I am going to continue doing projects because I believe in this concept. So I have the Raspberry Pi hat. So I have a brand new Raspberry Pi 5. I'm going to use the Raspberry Pi 5, the hat, in order to use this particular Blues note card, and hopefully that will solve some of these problems. Again, maybe it's my code. I mean, I don't think it's my code. Again, I went back and I cleaned up my code a little bit just to dot the I's and cross the T's. Now this part here, for deleting an additional note, this could be consolidated. So basically you could figure out how many notes there were and then delete any new notes up here maybe. I mean, I think there's some stuff here that could be consolidated a little bit, but there's nothing that should affect runtime. There's nothing that should affect latency. And again, I divided this out just so it's a little bit easier. You understand this is getting the message and this is deleting the note. So again, you could do that cleaner, but I don't think that would affect the performance of this. So yeah. So anyways, again, it's not a review, it's a class. I'm showing you it do what it does. You decide what you want to do. I'm not going to tell you what to do, but I will continue to play with this. I think this is interesting. Again, like with the Raspberry Pi, one of the things that I want to do is like two-way communication, essentially two-way text communication. Again, with that 500 megs, if all you're dealing with is text, imagine for field technicians, basically being able to send basic text back and forth. So again, if I have a Raspberry Pi, all right, I can create a little bottle. I can create a little bottle web app with input boxes and check boxes and all that kind of stuff. You get a field technician. Again, do that. They're interacting with a quote-unquote web app, but when they hit submit, that can all just be consolidated into a JSON stream that then gets sent back to headquarters. And so headquarters will get that JSON stream along with the current location of the vehicle or that field technician. They can read it. Again, they can either manually read it or an auto system or an AI system could read that, and then based off of certain information could then send back a command to them. Again, it could send back the value in JSON. And then when that JSON value gets to that Raspberry Pi, the Raspberry Pi could then create a very beautiful, web app page to basically to show whatever data that information is supposed to show. Again, maybe the next location that the technician is supposed to go to or things like that. I think what becomes very interesting in this modern world, again, with IoT and all these different things is, again, thinking about Again, how we design that architecture, right? Where does everything have to be? Can I have a metric crap ton of local files on a Raspberry Pi 5, right? A Raspberry Pi 5, you can put a 1 terabyte drive onto that thing. You could store a lot of local data, and then you could reference that data by IDs. So instead of sending maybe types of pictures or whatever to their device, you can send an ID to a picture that's already on the device, and then that picture can show up. So imagine like if you have a work order system, let's say you have a work order system, and with a work order system, people take pictures. So your technicians every day, they take pictures. Well, imagine those pictures go into this little Raspberry Pi. Now again, with a note card, you don't want to try to upload those pictures with a note card. One, it's probably not going to work, and two, it's just going to be a disaster. But imagine your technicians come back to your headquarters, your office, where they're on the Wi-Fi connection. Imagine your Raspberry Pi 5, their Raspberry Pi, then synchronizes, again, the database and all of those images back to your server. Once everything's on the server, it then synchronizes back out to all the fleet's Raspberry Pi 5, right? Since you can have a terabyte of storage or 4 terabytes of storage, you can have a lot of terabyte storage on one of these Raspberry Pi. So basically, every single truck could have a copy of all the data, images, everything that's sitting on the server, so that in the future, if somebody's like, oh, what does this house look like? A field technician is going to a house, or the field technician needs to see something, right? An ID can be sent to their Raspberry Pi. That ID references the image, and that image is just simply opened locally. So instead of having to send the image, you open it locally. And this is kind of some of the interesting things that I really think more people should be thinking about as we try to figure out how to design these systems. Nowadays, it's so easy to focus on LTE, 5G, IPv4, right? That's how you do it. And I think if you start thinking a little bit more outside the box, I think there's a lot more interesting solutions and more powerful things that we can do with all this kind of technology. So that's why I'll be sticking with blues a little bit longer. Again, I've been doing tech since 1996. I get it. There is no perfect tech. That's one of the reasons I don't have sponsors. You know why I don't have sponsors? Because sponsors only want you to say the good things about their product. Here's the thing, in the IT world, there is no good IT product. There is not a single product in the IT world that is good. There are IT products that are good for certain tasks and dog crap for other tasks. And so what you have to figure, you don't find the good product because it doesn't exist. You find the product that reliably deals with the task that you're trying to solve for. That's it. Again, I use Macs. Most of my computers are Macs. People are like, oh, Macs are horrible for gaming. Like, I don't care. I have a PS5. I go home, I play Prince of Persia on my PS5. I write code on my Mac. I don't care that my Mac can't play. I don't think I've ever played a video game on a Mac itself. That's how little I care. It's not about good or bad. It's about what the particular product does. And so that's why I'm sticking around with blues a little while longer, is that the salespeople have a damn good pitch. Oh, the documentation and the quirkiness, though, man. To be honest with you, anybody that's been around for a while, I haven't felt this way since NT4. If you really want to know how I feel right now with this, NT 4.0. That's the last time I felt this way about a technology device. But we're going to stick with it. NT4 made me a lot of money. NT4 was quirky as hell. Made me a lot of money. So we're going to stick with this. And hopefully in like a month or two, I'll be doing some really awesome projects. Anyways, as always, I enjoy teaching this class. I hope you found it slightly enjoyable. If you are the CEO of Blues, hi, how you doing? Got a good sales pitch. Anyway, with that, see y'all later.